Hi all. In this video, we're going to start our conversation about the Boolean data type. We'll go on from there to talk about how we use Booleans inside conditional statements in Python. But for this video, we're really going to focus on the Boolean data type itself and the values that belong to it, the operators and functions that we can use to manipulate and express Boolean expressions, and just give you a sense for what this is all about. All right, so here is where we're going to start our conversation. This is a picture of George Boole. Boole was a mathematician from England, and he was very interested in connecting what had been up to that point different aspects of the field. So connecting the kind of numerical calculation based reasoning that was done in mathematics at the time with logical reasoning, which was mostly held in, say, a philosophy department. So logical reasoning is about proving things, and mathematicians were also interested in proving things, and he was trying to find a way to connect them together. And he did, in fact. He found a way to represent true and false as values, and he developed a Boolean algebra, a set of rules for how you can manipulate Boolean expressions. This was kind of a niche. It wasn't very important for a very long time, but when computer science came along, when we created these digital computers, all of a sudden what Boole had been working on was absolutely essential. It is the heart of how hardware works, computer hardware. It is the heart of how we make programs that can make choices. It's very, very important stuff. Fortunately, it's not super difficult, and so we can learn it and make sense out of it. So here I'm going to talk a little bit about the Boolean data type. This is another kind of data in Python. We've seen numbers, floating point and integer, and we've seen strings and lists. So this is a data type like those. It's built into Python. It is in some ways very simple, but it is also very powerful because, as I said, this is foundational to how computers work. So when in the Boolean data type, there are only two constant values. So we have an infinite number of strings, an infinite number of numbers, an infinite number of different lists we could make. But in Boolean, you just have two values. You have true and false. And in Python, they are written this way with a capital T, RUE, capital F, ALSE, no quotation marks, nothing else. They are constants that are built into Python. What we have is a lot of tools that allow us to use those to build expressions that result in Boolean values and to combine those expressions together. So I have a couple of examples here of things we've actually probably already seen a little bit. So I can say x less than 25 in Python, and that is essentially asking a question. That's saying, is x less than 25? And that question has an answer which is either true or false. Similarly, I could ask whether an element of a string is less than some other string. And again, that would have a true or false result. We also have some operators. I'm going to talk about that in a moment. What I'm actually going to do is to switch over to a different document. This is our in-class activity document because this has a few more details than I have in my actual notes. So again, this is a Boolean data type. It has constants true and false. What I've listed here are a set of really common Boolean expressions. So these are questions that we can ask where the A and B can be almost any kind of data that you might run across in a Python program. So if I want to ask, is A equal to B? I use a double equal sign. That looks a little unusual, but we want to distinguish this double equals, this question about equality, from the assignment operation that uses the equal sign to assign a variable to hold a value. So because we need to make those distinct, we use two equal signs when we're asking the question. Is A equal to B? We have a shorthand notation here, an exclamation point followed by an equal, which stands for not equal to. Is A not equal to B? So that will be true if they are different. We have less than or equal to, which is a less than sign followed by the equals, or less than all by itself, greater than or equal to, or greater than. Those are sort of natural extensions of things that you might have seen in math class before. All of these are asking about the relative size of the two elements, or relative ordering of them in the case of strings. In is a Boolean operator. We've seen this one already, examples of it. We haven't really talked about it, how you would use it. So A in B allows us to ask, B has to be usually a sequence type of operator, or a piece of data that holds multiple pieces of data within it, because what we're asking is element A in this particular data type? So if we have a string, we can ask whether a substring is in that string. If we have a list, we can say, is A an element of the list, and so forth. A is B is kind of a subtle one. We're not going to use it a lot, but I think it's worth knowing. It's also asking about equality, but in a different sense. It's asking if these two pieces of data are actually the same data at the same location in memory. So whereas double equals is asking whether they look the same, is saying, are they actually the same? Now, I have some examples here. 25 is 25. That's true, because a number is a number is a number. There's only one canonical 25 in the universe, and it is the same 25 as itself. But if I ask, is 25 25.0, you get a false result, because the first 25 is an integer value and 25.0 is a floating point value. They are not the same. They are not represented the same inside the computer. So they are not equal in that sense. If I use the double equals, if I said 25 equal 25.0, I would get true, because they look the same. They're basically the same value, but they are not the same type. So they cannot be the same actual data inside the computer. So if I also do this, two lists, even though they look the same, they may be in different places in memory, and that's where is gets used a lot, is determining whether that's the case. All right, I'm going to do a few examples. So let's switch over to PyCharm. All right, so we'll just put some numbers in and then try some things out. So I'm going to say x equals 50, y equals 150, s equals, no, I don't want to capitalize it. That'll just make things complicated. I'll make s be a string. All right, so given these values, what we're going to do is test some Boolean expressions and see what they do. So suppose I say x less than y. What would we predict that would return? What about equality? X should be less than y, so we should get a true for the first one, and for the second one they're not the same value, so I would expect to get a false. Now I'm doing this in this file. You can also run the Python console. We were using that before. Let's restart it. We were using that before for a different activity. I can just do the same thing here. I could say x equals 50, y equals 150, s equals apple cart. And then I can just type these Boolean expressions right in here. X less than y. That gives me true. X greater than or equal to y. That gives me false. X not equal y. That should be true, and so forth. I could say PLE in S, and that should give me true. But if I said app with a capital A in S, that will give me false. So I can try out these Boolean expressions and see what they do in this context. And in the activity to come, you will try some and try them for yourself and see if you can figure out what the answers will be before you actually run them. All right, I want to talk then about ways that we can combine these together. So suppose that I have these three numbers. Get rid of my s. I have x equals 50, y equals 150, and z is 75. And maybe I want to know if y is the middle value of the two. I can actually do this in Python with just a simple expression. If I know what I'm doing, I can put together an expression like this. So this says, is x the smallest and y the middle and z the largest? Right? In order for this to be true, x has to be smaller than or equal to y has to be smaller than or equal to z. So z would have to be the largest value of the three. It says false because yes, y is 150 here, but I could say, oh, well, z and y, and then I will get a true value. But suppose I just wanted to know whether y was the middle value or z was the middle value of the three, and I didn't know whether x was less than or greater than y. This won't work if x is greater than y. So for instance, if I say, if I change the values, so x is 250, y is 150, z is 175, z actually is the middle value of the three, but this expression won't tell it to me. It gives me false because x is not the smallest. So what I want is to be able to say, is it either this ordering or is it a different ordering, right? So I could also ask, print y less than or equal to z less than or equal to x. That's the other possibility, is that y is the smallest, x is the largest, and z is the middle. Those are the only two ways that z could be the middle value. So I can run this, and if either one of these returns true, then it means that z is the middle value. And that's the case here. But I couldn't get at that with just this expression alone. We have these three Boolean operators that let us put together Boolean expressions and ask more complicated questions. So I can ask, I'm going to separate the printing from the actual expression here. So I'm going to say answer equals x less than or equal to z less than or equal to y, or y less than or equal to z. There are different ways of doing that, but this is one way to do it. So here I've used this Boolean operator OR, and I've used it to combine together two separate expressions. If this captures both possibilities, if z is the middle value, one or the other of these will be true. They could both be true, but only if all three values were the same. So now I get a true result, and if I set these back to my original, I should also get a true result. It's hard to tell because it's only printing the one thing. So OR is one of these three operators. There are two others, and not. They have two different meanings to them. Let's go back to these notes and take a look. So here you see the Boolean logical operators, A and B, A or B, or not A. So A and B here are placeholders. They stand for any Boolean expression. Any of those kind of x less than y, anything like that that I might build. So this will be true only if both parts are true. So I could say, is x less than 100 and y greater than 100? A or B is true if either one of them are true. So this one is more flexible, this one is more restrictive, and not A just flips our value. So we could say not x less than y. That's actually the same as saying x greater than or equal to y, but you can write it that way. And there are times when we have to write it in that particular format. So I have, in the activity, we have a set of examples. I'm going to copy these over to PyCharm and we'll take a closer look at them. All right, so I'm gonna space these out. I put them all together in my notes, but I find them hard to read that way. So we'll take a look at one at a time. Are x and y multiples of 5? Both of them need to be multiples of 5. So here, this is a way to check the multiples. I can use that modulo remainder operator. So divide x by 5 and look at the remainder. If it's divisible by 5, the remainder will be 0. So x remainder 5 equal to 0 means that x is divisible by 5. And I'm asking then if it is also the case that y is divisible by 5. The second case, does s start with a b or is it more than 10 long? So I have two different questions about s, and I connect them with an or because either one is fine. Either starting with a b or being long makes it acceptable. Does s not contain the character I? This is an odd notation. I not in s. We would normally think of it saying not I in s, but this is a little more grammatical English-wise, and so it is permitted. Not s sub I equal to a. So is the one position character in s not equal to a? So this is a way of asking that question. Is x in nums and y not in nums? So I'm using the not operator and the in operator and to put those things together. All right, so these are a lot of different examples. Hopefully this gives you a sense of how we can build Boolean expressions. Boolean expressions are very important. You can make Boolean expressions of almost any complexity. Sometimes there's just one simple little expression. Sometimes you might have one that goes on for several lines of your code. We're using those here just to give us true and false answers. In practice, most of the time, we're using those in the context of a conditional statement, and that will be the subject of our next video. So until then, I will see you very soon.